So, hello students, welcome to Science Affair, a one-stop YouTube channel for physics. So, hi, I am Deepak Barnwal and your physics faculty. Today we will start Electrostatics 1. That means class 12. Yes, class 12 is started. So, if you have any doubt in class 11, so go first clear that doubt that we will mostly use the laws of kinematics, the laws of motion in this class 12. Okay, class 12 is slightly tougher than class 11. Why? Because we will study the charge. We don't see the charge. We will study the current, electric current. We don't see the electric current. We will study the magnetic field. We don't study the magnetic field. So this will happen now. So we have to be strong imagination. So don't worry, I am with you. So let's try. So there is a famous quote by Guru Ugwe that yesterday is a history, tomorrow is a mystery, but today is a gift. That is why it is called a present. So what does it mean? What Guru Ugwe said that yesterday it is already past, no? So don't go to the past. Don't think about it. It is already past. Tomorrow is a mystery. Means what will happen tomorrow? It is not in our hand. So don't think. Don't think. And today is a gift. Means what we have present. That present day, today. So hard work. We do hard work with consistency. So that for this quote, we are starting our class 12 journey now. So what will we study in this chapter? First, we will study the charge and its properties, then method of charging, then gold leaf electroscope, what is gold leaf electroscope, and Coulomb's law. Most important part, Coulomb's law. So, for the first lecture, first two lectures, these are our topics. First, we will start from charge. Charge, how many types of charge, what are the properties of charge, method of charging. Let's start charge. Before we further continue with the charge, first tell me about what is mass. Mass. So it is a property of a body. Like earlier classes we have read, it is the property of the body. Property of the body. What is this? It is a property of a body by which it can experience a gravitational force which is called weight. Weight. And we know that weight equals to mass into acceleration due to gravity mg, and SI unit is Newton, capital. Likewise, come here, charge. Charge. Keep your mobile in charge state. So that is charge. What is charge? It is also the property of a body. It is property of the body which in which it experiences a force force when placed in electromagnetic field. Electromagnetic field. Understood? In this electromagnetic field. Now, What is the SI unit of charge? SI unit of charge. SI unit of charge is Coulomb. Coulomb. Capital C we will represent with capital C, and charge will represent with Q. Capital Q. Okay. And if we are talking about unit, just tell me what is smallest unit of charge? Smallest unit. And another largest unit? Largest unit. Just remember, smallest unit is Franklin. Franklin, and largest unit is Faraday. Faraday. Okay. Franklin and Faraday. These are two units of charges, and SI unit is Coulomb. Now, next. Now, charge can be at rest, can be with constant velocity, which is called current electricity, and one accelerated motion. So, if charge is in rest position, it will produce electric field. Magnetic field and electromagnetic wave it will not produce. If charge in constant velocity, means here is a plus Q charge and it has VD. VD is drift electron. We will see in the current electricity chapter. So with constant field, constant velocity, it produces electrostatic field or electric field and magnetic field also, but do not produce electromagnetic wave. But if Q charge is an accelerated motion, that means it has acceleration, means momentum is changing. So then we can say it has electric field, it has magnetic field, it has electromagnetic waves also. Understood? Like light is electromagnetic wave. Like X-ray, X-ray is a part of electromagnetic wave. Like gamma ray is a part of electromagnetic. So on. After this, properties of charge. Look, there are two types of charges. One is positive, as we know, and one is negative. What is known by quantization of charge? Quantization of charge is represented by, first tell me, charge is represented by Q, no? And it is integral multiple of electron. Like if I ask, in the classroom, in one classroom is there. I ask how many students are there. Someone came and told 25.5 or 2.5 students are came. So this can't be possible, no? It's like impossible. So what happened now? Classroom is made up of integral multiple of students, that 25 students, 9 students, 6 students, and so on. We can't root 3 student not happen, not possible. Root 5 student not possible. Root 25 student possible because it is 5. 5 is present. Okay. Likewise, n belongs to integer. Integer plus 1, 2, 3, 4, 5, 6, 7, 8. Now, again, conservation property of charge. Net charge is constant. That net charge of for an isolated system is constant. Additive in nature is scalar. It is scalar quantity, so we can add the charges. It is transferable, means one from one body to another. It can be transferred. Exists only with the mass, no without the charge. Means without mass, charge is not possible. Without mass, charge is without mass, charge is not possible. Without mass, charge is not possible. Okay. So let's move further. Types of charges. There are two types of charges. There are two types of charges. One is positive charge. Another is negative charge, negative charge. Acha, tell me, this is an atom, hydrogen atom or helium atom. So it has two proton, two electron. So tell me which is transferable, electron or proton? Of course, sir, electron is transferable, proton is in the nucleus, so it cannot be transferable. So electron is transferable. So where if electron loses, if an object loses electron, then it is positive charge, and if gain electron, if any object gain electrons, it has negative charge. Okay, like one famous example is silk cloth or hair and comb. We rub each other, na, hair and comb rub each other. So what happened? Comb will get negative charge and hair will get positive charge. Understood? Positive, negative. But all the charges are constant. Means how much positive the hair will get, that much negative comb will get. This is the thing you need to remember. Next, quantization of charge. So charge is always integral multiple of charge is always integral multiple of electrons. That means charge Q equals to n times E. Q equal to n times E. So there is one question. Find number of electron. Find number of electron in 1 coulomb charge. In 1 coulomb charge. So Q is given as 1 coulomb, and we don't know. And electron. What is electron here? Electron means charge on electron. That is 1.6 into 10 to the power minus 19 coulomb. Okay. So this is the given, and now we will solve. This Q1 equal to n times 1.6 into 10 to the power minus 19 coulomb. N equal to 1 upon 1.6 into 10 to the power minus 19. It will go up and get positive index property. So n equal to 1 by 1.6 into 10 to the power 19. When you solve this now, it will come 0.625 into 10 to the power 19 electrons, and we can say n equal to 6.25 into 10 to the power 19 electrons. Okay, 19 electrons. Next, so this is the thing we have to remember. So if they ask how much electrons are present in 5 coulomb. So in 1 coulomb, this much electron is possible. So in 5 coulomb, 5 into this much electron. If 10 coulomb, 10 into this much electron. That's unitary method only. Now, again quantization of charge, that Q equals to NE. So one question, again find number of electrons in 5 coulomb. So 5 equal to n times 1.6 into 10 to the power minus 19, and n equal to 5 upon 1.6 into 10 to the power minus 19. This will go up with 10. So 5 into 6.25 into 10 to the power minus 19. This much electron is possible. ओके, सो चलिए नेक्स्ट इस क्वेश्चन को देखते हैं. स्मॉलेस्ट यूनिट ऑफ चार्जेस, टेल मी, ए बी सी डी. So right answer is Franklin. Very good. Next, if a body has positive charge on it, then it means it has gained some protons. nahi, we cannot gain any proton. Lose some protons, we cannot lose any proton. Gain some electron. If it is negatively charged particle, then gain electron. If it is positively, lost electron. So D is the correct answer. Sure check of presence of electric charges, like C. Like charges, that plus plus charges repel each other and plus minus charge attract each other. So presence of charge na, it is said if you read the book S.C. Verma, that they have written the presence of electric charge sure check is repulsion between two bodies, because in attraction there is gravitational force. Now conservation of charge. What is conservation of charge? See, total charge of an isolated system, total charge of an isolated system is constant, or the previous one, the definition we are wrote in class 8, that charge can neither be created can neither be created nor be destroyed, but it can transfer from one body to another. Neither be created nor be destroyed. Okay, it can transfer from one body to another. Like charge inhalation. Example: charge inhalation. Charge, what charge inhalation says? It says that two gamma rays produce one electron plus one proton, one positron. So before the charge was 0 and after the charge is 0. So total charge of an isolated system means we cannot add or subtract from the system. This is called isolated system, is always constant. Now invariant nature of charge. Likewise mass, again we will compare with mass. Okay, mass depends on speed of object. Speed, like mass at velocity v will be m naught, which is original mass, root under 1 minus v square by c square. As you increase speed, mass will increase. Okay, we increase this and this whole has decreased, mass will increase. So, but charge does not depends on speed. Why this? Because charge is invariant. Charge is invariant and mass is variant. So we can say mass is variant. Mass is variant. And nothing like this happen, guys. Q equal to Q naught upon root under 1 minus v square by c square. This is not true. This is not true. Okay, this is true. Correct? This is wrong. So remember this. Which of the following is not true about the electric charge? Not true. Remember this. Not true. So saying charge on a body is always integral multiple of certain charge known as electrons. Right. Correct. And charge is a scalar quantity. It is also correct. Net charge on a body is as always considered. It is also correct. So it is wrong. So our answer is this. Charge can be converted into energy. It cannot be converted into energy or mass. Select the now correct statement. Charge can be converted into energy. It is false statement. Charge of a particle increases with increasing velocity. It is also false statement. Charge is invariant. Charge on a body is always integral multiple of a certain charge. Is called charge of electron. Right? Correct. So this is also wrong. Option C is the correct answer. Next, a glass rod is rubbed with a silk cloth. Okay, just try it. Okay, just pause the video and try. Hope you tried. So first we will write given. What is given? A glass rod is rubbed with a silk cloth. The glass rod acquires a charge of 19.2 coulomb, 19.2 into 10 to the power minus 19 coulomb. So Q is given as 19.2 into 10 to the power minus 19 coulomb. Find the number of electrons lost by glass rod. Lost by graph. Means N equal to what? E is 1.6 into 10 to the power minus 90. Now we know that Q equals to N times E. So Q is given 19.2 into 10 to the power minus 19 equals to N times 1.6 into 10 to the power minus 19. This minus 19, this minus 19 cancelled. N equal to 19.2 upon 1.6. Point will cancel out. Now 16 12 ja 192. 12 ja 16 12 ja 192. So when 12 electrons are there, the number of electrons is 12. Okay, hope you understand. Next, what is conductor? What is insulator? So like copper is a conductor, aluminum is a conductor that which allow the charges to flow from them. It is called conductor. And the material which do not allow the conductor, do not allow the electrons to flow from it, it is called insulator. So remember this, like aluminium, copper, iron, it all, this gold, silver, this all are conductors, and it is best conductor. Best. And again, this rubber, plastic, these all are non-conductor. Yes. Now, methods of charging. Method of charging. There are three methods of charging. We will see. First method is conduction. Second method is friction, and third is induction. Induction means without touching, without touch, and friction with rubbing. Both the bodies get equal and opposite charges. Okay, just remember for this. Conduction. Now we will see the conduction in detail first. Now see conduction. So with conduction, to study the conduction, we will take two spherical charge bodies. Okay, with radius R2 with radius R1, R1 and R2 radius. Okay. So what will we do? That let us assume earlier it has Q1 and it has Q2. Then what we have done, this all are conductor 1, conductor 2. What we have done, that we have attached one switch and wire, and when we close this at t equal to t, both conductor has that this one has q1 dash and it has a q2 dash. Okay, what we can write by conservation of charge, q1 dash plus q2 dash will be equal to q1 plus q2, q1 plus q2. And one more thing, if we are studying here, no, that if there are large sphere like this sphere, so it will get more charges are there. So q is proportional to r, so q1 proportional to r1 and q1 by q2 is proportional by or equal to r1 by r2, and q1 can be written as r1 by r2 into q2. Now after touching, q1 dash will be equal to r1 by r2 dash, r1 by r2 into q2 dash. So in place of q1 we place this thing, no, like q1 dash, in place of q1 right here r1 by r2 plus q2 r1 by r2 plus 1 into q2 dash equal to q1 plus q2. Okay, now what we can do, that we know that q1 plus q2 is this, so we can just write no, q2 equals to q1 plus q2 upon here r1 by r2 plus 1 q2 dash. Like if we know q2 dash, we can write from here q1 dash also from equation 1. From equation 1 find q1. Okay, so this is a thing we can go through it. Charging by conduction is done. Now charging by friction. Let us assume two bodies, two bodies, silk cloth and glass rod. It is before scenario, it is after scenario. So before, the silk cloth have zero charge and glass rod has zero charge. It is silk cloth, it is glass rod. This. Okay. After, silk cloth will get minus n electron and it will get plus n electrons. Okay. As you see, both charges are equal and opposite to each other. So remember, if one body get plus 1 charge, another body will get minus 1 charge. And for here, negative charge will go through silk cloth and positive charge will go through glass rod. Likewise, one more example are there, that hair and comb. Comb will get negative charge, means it will gain electron, it will lose electron, it is positive charge, lose electron. Okay, so after this we can further move by induction. So what is induction? No, induction means without touching, without touching, without touching. Let us assume there is a ball, and what I have done, that I have placed near ball positive charge, very much positive charge. So in this ball, negative charge will become here due to attraction of this positive charge, and positive charge goes through here due to repulsion of this positive charge. No, this is step 1. Now see step 2. Now this is again negative, 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 and positive, 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 positive. This is positive, 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 positive charge there. Now get earth, do earth. So what will happen? Electron will come here, electrons, and get this positive charge to the negative charge. So what happens in step 3? We remove this bar, this rod, and it will have negative, negative, negative. Again negative will come from here. So total will be separated negative here, negative block, negative, negatively charged. One more thing I can write here, that rod will never lose or gain electrons. Means charge is same for rod, only that sphere get charged. Next, consider a neutral conducting sphere. Okay, a neutral conducting sphere are there. A positive point charge q is placed outside a sphere, that means here positive. Then the net charge on the sphere is negative and distributed uniformly over the surface of the sphere, negative, and appears only at one point on the sphere closest to the point charge, negative, and distributed non-uniformly over entire surface of sphere, or 0. Consider this thing. Okay, let's consider. So I want to you that this is your homework. Do in comment section. Do in comment section. Remember, this is part of induction. Okay, think about induction here. So you will get the answer. So and here, when 10 to the power 14 electrons are removed from neutral conductor metal sphere, then the charge on the sphere becomes, if 10 to the power 14 electrons, means n is given as 10 to the power 14. So we can say q equal to n. So q will be 10 to the power 14 into 1.6 into 10 to the power minus 19. Minus 19. 10 to the power 14 and minus 19. So 1.6 into 10 to the power 14 and 19 means minus 5 is there. Minus 5 coulomb is there. So we can write 16 into 10 to the power minus 6. That means coulomb, and 16 micro coulomb. 16 micro coulomb. Remove no, so positive will come in the neutral conductor. Now read. This is your homework. Read this. Okay. So that's for today, guys. In next class, we will do gold leaf electroscope and numerical law, Coulomb's law, and the numerical on it. So thank you for today's lecture. Thank you for your time. We will see you in next class. Bye.